is Registry of Deeds, and this is our team.
Hey, I'm Arian Tripathi.
Hi, I'm Alan Lin.
I'm Danai Sinanan.
And I'm Nolan Mackey.
So, a brief rundown of our clients. Our clients are Laura Marino and Bridget O'Connor from the Hampton County Registry of Deeds. So, basically, they maintain property records such as deeds dating back to the 1600s. And their mission is to preserve these deeds records and make them accessible and searchable to the public. So, our problem statement is trying to transcribe these valuable historical records since they're in handwritten, cursive, and typed documents into digitable and indexable text. So currently there's 100,000 records dating back to the 1600s, and some of them are cursive, and there's no searchable index, which makes them times consuming to search through.
This is an overview of the architecture of a project. All of the data is stored on the BDU shared computing cluster, and that consists of 100,000 plus historical documents, and they are in the form of PDFs and TIF documents. Then we can see those documents through our user interface, which is in the form of a Streamlit web application. And in that, we can see a PDF preview of all of our documents, and also process batches. And then we have our multi-model OCR pipeline, where we can process documents in parallel, and we can see the cost of processing these documents and the confidence of our models. And then finally, we can look at our models. We have ChatGPT Vision, DeepSeek, and Tesseract. ChatGPT is our highest accuracy model, but is also our highest cost model, and DeepSeek and Tesseract are both open source free models, but the results have varied for our project. And finally, our web application outputs a structured output, which consists of JSON and metadata, as well as a confidence score. And it's structured in the form that we can see the grantee and grantor names, the dates of the transactions, the book and page references. We can also see property descriptions, financial data, and geographic information.
So this is gonna be our first deliverable, which is the Streamlit application. As we can see, it's the local file browser running on the SEC cluster, and as we can see, we are able to like preview documents on each specific page of the document as seen here. And yeah, so we can see that after viewing this, we can change the page, and we can also select the model that we want to use for the transcription. What this is gonna do is gonna run OCR and then parse the text using an LLM. And we can also select a range of pages for any specific document. We're gonna showcase here how it's gonna go. It does take a while, so we're gonna skip to the results here, and we're gonna show the results as they are on the OCR, and this is from the ChatGPT with a 90% accuracy, like confidence score. We can see that the records are shown in this way. Yeah, so the next one, we're also gonna try the DeepSeek LLM, the DeepSeek like pipeline. So we created an end-to-end pipeline with the user interface where we can basically select the documents we want to process, and then process all the records from those documents and output them to a JSON file, which is shown on the front end. As we can see, it's basically the same thing after the DeepSeek one continues running. And we can see that these are the records that it comes up with the fields required, like the year, book number, page number, and this is the JSON or JSON returned. So we also created a final deliverable for the client, which was deployed front end, where we can search through the results we've made so far. So far we've processed about 13,875 pages, which have around 411,920 entries from different books. And we can also make it so we show a paginated table where we can change the pages. We can sort those records by any time, and we can also search grantor grantee with like contains. So we can search for a name, and we can see all the records that have basically that name in it. Here we can see how we can change the pages on the table that is shown, and also the fields. We can see that we also store the source file of the code. And we can also filter through the source files, so basically in the same structure that we have from the files given to us from the client. Instead of just having the raw PDF files, we can just filter through the JSON results of each specific file and basically mix and match it with everything that we have. We can also, these are also the things we can sort by. So we have the year numeric, grantee grantor name alphabetic, the book number, book page numeric, and also the source and page number.
All right, so these are the key findings for our project. So we have ChatGPT Vision, which we have found that is the best for handwritten cursive documents, or just kind of any documents that aren't in easily readable form. And that also has a price of about $0.025 per page. And then DeepSeek, which is good at handling the complex layouts of all of the different documents, while also being free. And then the hybrid model is just using either DeepSeek or Tesseract in conjunction with ChatGPT, and that is great at handling a large number of pages with a decent accuracy. And then we have Tesseract, which fared well with our typed texts. Our VLMs outperform traditional OCR on handwritten texts, but at typed documents, the comparison is much closer. And then we can also use parallel processing to speed up the amount of time it takes to process a large number of documents. And we can use our confidence scores to enforce quality control.
Yeah, so for relevance, I mean, there are a couple different stakeholders that this project could touch. It could be just like individual families in general, just trying to see like how their own family history kind of evolved through the history of America. There's also like the community in general, trying to see like how these towns and neighborhoods evolve. But at the end of the day, the biggest stakeholder is going to be the Massachusetts Registry of Deeds themselves, just so they can see like how these property rights are interacting with each other and the various different relationships that are involved among these deeds. And for the value added, we think that this is a very valuable project because previously it seems kind of intuitive that it would take a lot of time for these people to search through these handwritten or typewritten documents that are not digitized. So being able to convert these to a digital form that can be indexed and then searched through should save a lot of time and energy for the Massachusetts Registry of Deeds. And it should allow them to have a much more streamlined process for doing these specific individual name and property lookups. And in terms of scalability, we think that there are possibilities for integrating a database so that instead of just having an individual like lookup basis, you can convert every single document and store them in a database, and that database itself can be queried into and just have a sort of holistic storage of all the documents themselves. We think that there are opportunities for quality control in terms of human-in-the-loop validation, where some of the documents that have lower confidence scores could call for some sort of human validation or a human input to ask for a better model to be implemented or used for the less confident results. We also have options for fine-tuning these OCR models just so that in general they'll be producing higher confident results. And then also the possibility for a distributed system, because one of the bottlenecks involved was GPU usage. So being able to process multiple documents at once could be a valuable thing to pursue in the future. And yeah, that kind of wraps up our project. And hopefully this was valuable and insightful for you guys.